So piecewise functions, the only difference is you have multiple functions combined into one. So different parts of the domain have different rules. So for example, with here we have f of x is negative 2x if x is less than negative 2, as x plus 1 if x is greater than or equal to negative 2. So to plug values in, very similar to what you're used to, and f of negative 3, you would just look to see that negative 3 is less than negative 2, which means we're going to use this top function. So we do negative 2 times negative 3, and we get 6. Okay, so now we know that means the point negative 3, 6 is on this graph. And the second one, f of 0. F of 0 is greater than negative 2, so therefore we would plug it into the bottom equation. We would just get 0 plus 1, which equals 1. So we know the point 0, 1 is on the graph. Then for the last one, for f of negative 2, here's where we have to notice the top one says less than negative 2. The bottom one has that or equal to, so we would use the bottom equation. Negative 2 plus 1 is negative 1. So we know the point negative 2, negative 1 is on the graph. So when you're plugging in, you just follow the domain rules. You only plug into the part of the function that fits in the domain. Piecewise functions are just functions that have different rules for different parts of the domain. So for example, the one on the screen right now, when x is less than negative 2, we're going to be graphing the graph negative 2x. However, when x is greater than negative 2, we're going to have the graph x plus 1. So all we need to do is graph these two lines, but they're only going to be present where the domain says they should be. So for example, a good thing to start is that x equals negative 2, right here. If you just want to draw a little dotted line for yourself so you know that's where our graphs are going to switch. We're going to go from the red graph to the blue graph. So now we just need to graph them both. To graph the line negative 2x, well, it's like having a plus 0 on it, so the y-intercept is 0. Point right there, a slope of negative 2, so up 2 over 1, up 2 over 1, up 2 over 1. So those red dots represent that graph. I'm not going to shade anything in yet, so I can show you what to do to put them together. Then for our second graph, x plus 1, okay, y-intercept of plus 1, slope of 1, so down 1 over 1, down 1 over 1, so forth. So when x is less than negative 2, so from this line to the left, that's where we're going to have our red graph, negative 2x. So you can just go ahead and start connecting the dots only to the left side of negative 2. And then when x is greater than negative 2, so from here to the right, that's where we're going to have the blue graph. So we want to start at negative 2, connect our dots to the right. Now the other key to look at is the fact that the bottom one says x is greater than or equal to negative 2. So if you remember, a function can't have 2 points on a vertical line. So right now at negative 2, it looks like we have 2 points. Since the bottom one is where it's greater than or equal to, that should be a closed circle. Whereas this top red one, that's when x is less than negative 2. That should be an open circle up top. Okay, we're going to do one more. This is the one from the textbook from example 3 on page 57. This one has 3 parts to it. Still the same idea though. So first, let's just look for where the domain's going to switch. So if you look over here at all these domain values, we know at negative 3 something's going to happen. So negative 3. And we know at 1 something's going to happen. So over here at 1. And you don't have to draw those lines, just kind of helps give a visual. So first, let's do this negative 2x plus 1 graph. So we have a y-intercept of 1, slope of negative 2. So if we're going to the left, that means we have to go up. 2 over 1, 2 over 1, and keep it going. Okay, and then our second graph is that when x equals 1, we have a value of 2. So just f of x equals 2 is a horizontal line. And then we only care though, so if we were to draw it, it would be that whole horizontal line. However, this is only going to happen at x equals 1. So really the only point we're going to care about on that is the point that when x is 1, y is going to be 2. And now we have our third graph, which is going to be at x squared when x is greater than 1. So we know the graph of x squared is a parabola starting at the origin, up 1 over 1, over 2 up 4, over 2 up 4, over 3 up 9 somewhere. So now it looks a little messy. I just have to shade everything in. We had our red graph between -3 and 1. So here was -3. This line is 1. And notice it's less than or equal to -3, so closed circle there. We didn't go down far enough, and an open circle at 1. So there's that graph. Okay, that 2 is just for that 1 point, so we already talked about that. We have our 1 point for at 2. And then when x is greater than 1, so that's here to the right, we're going to have that parabola graph. Now this is just greater than, so that should be an open circle, not the clearest on this technology, but you guys get the idea. And then the parabola goes up to the right. So the graph in this case, notice to the left, there is no arrow on that red. It starts at -3. We don't have anything prior to -3 in this domain. So really, if we were talking about the domain of this function, it would start at -3, -3 would be included, and then go all the way up to infinity. Because we continuously have a graph from there on out, but not prior to -3. And then at +1, that's when our graph jumps all the way up to the blue part, and then jumps back down to the green, where it'll continue up to infinity. So that arrow is important on the green side.